Welcome everyone to the technical manual for 1D hydrodynamic modeling using GeoHECRAS, presented by Ahmad Rifki. Firstly, we will go to the pre-modeling setup. We need to first define the project data units, which is SI units. Then, we can define the scenario name in the scenario manager. First, define the scenario name, the geometry data name, and unsteady flow data name. We can have multiple if we have multiple scenarios. Next, we will need to define the coordinate reference systems CRS, or which is commonly known as projection. So go into Asia, Southeast Asia, choose Malaysia, and then depending on where is the location of your project, choose it. If it's peninsula, you may select peninsula. Double check at the bottom right to see if you're in the correct projection or not. Next, we can add a base map. We choose Google Hybrid as the best choice as it has most of the data which is available. We can adjust the transparency. And the next step is to insert the shapefile. It is as easy as dragging and dropping the shapefile into the software. The first one will be 4 important shapefiles we need, which is river ridge, cross-section lines, river banks, and finally river basin. If you need to add extra shapefile, you may add it as you want. We also have the option to customize our shapefile. For example, customizing the color, customizing the thickness, and also transparency of the elements. Now, we move on to the river network setup. So first, to make it neat, we remove all unnecessary shapefile and only remain the river ridge shapefile. We will use this to generate it. In the river ridge section, choose Assign River Ridge, and it will prompt us and we can pick the polygon or the shapefile here which we want to assign as our river ridge. And take note, there is an arrow here to show you what is the direction of the flow. So make sure the flow is in the correct direction. Then, click Add New River to name your river. In this case is Sungai Jawi. Hooray! You have generated your river ridge. Now we're going to draw the river ridge manually this time. So click Draw River Ridge and select Draw. And it is important to note that the first point must intersect the main river. Then we can proceed to draw the river based on the bank lines up until the point which we want. And once done that, remember, check the river direction if it's in the correct way, and then we can rename our tributaries. In this case, our tributary name is Sungai Junjung. Now look at the intersection point. When we click apply, it prompts us to ask if we want to create a junction or not. So that is why it is important that the first point must intersect. So now the junction is automatically created and the main river is now divided into two. If we click at the bottom, we see that the name has been renamed automatically. So we would like to rename it as our own Sungai Jawi downstream. But oh no, it is too long. So to make it easy, we just name it Sungai Jawi DS. As for the upstream part, we can rename it as Sungai Jawi US upstream. There we have it. This is Sungai Junjung, and double check it is a tributary of Sungai Jawi. And if we double click on the junction, we can also rename it to whatever we want. In this case, I'm going to name it as Junction 1. Now, let's say you've drawn the river and you're not satisfied with the shape. You actually have the option to edit it. So, right click on the river, choose Edit Vertices, and you can drag and drop the vertices to any position which you think is suitable. Once you're satisfied, right click and select done, and you have edited the river vertices. And there you go! Congratulations! You have defined your river ridge, which consists of the main river and the tributary. Now, moving on to cross-section, let us turn on the cross-section shapefile. Then go to the cross-section, select Assign Multiple Cross-Sections. Here, we're going to assign multiple cross-sections based on the shapefile. Now, select the shapefile, then right-click, select Similar, then right-click again, and done. Downstream, which is the downstream name, we're going to put it as 0, and then you're going to put channel flow length so that it will follow the length. And we untick the data, elevation data, and click Assign. Wait for a few minutes, and there you have it. All of your cross sections are now automatically defined based on the shapefiles. It is so fast compared to using conditional or traditional HECRAS. Now, you want to make it faster, we can use the shapefile of our riverbanks, and we can define the left and right bank for all of the cross section in a simple click. So let's click to Assign Entities, Assign Channel Banks. Then we're going to select all, and we're going to now choose the shapefile which we're going to define as our left and right bank. So select the left and right bank shapefiles, right click, select Similar, and then look closely. Once we click OK, the left and right bank will be generated. There you have it. You see the red points now move to the left and right bank. So we also have the option to edit the cross section. So now here, if we click Edit Vertices, we can edit the cross-section vertices just like we did in river ridges. We can also drag and move the cross-section position. Now, we can also edit the Manning's information via this option here. This will show all of the river cross-section, and you can change the Mannings in here. As for boundary, go into unsteady flow data, and these are all of your boundary condition points. If we click Define, we use the simulation time, and usually we would choose 15 minutes interval. And if we go to our and we check the chainage, we go to our inflow here, select the inflow for the appropriate subcatchment, copy and paste, and we can have a look at the hydrograph, and we can repeat the process for other inflow as well. And there you have it. Now we can proceed to run our model. So go into Analysis, Compute Unsteady, choose Current Scenario. Then we can define our simulation time. And then we can define the computational time step. The lower is usually the better. Choose Mixed Flow for this one. Then once OK, we select Compute. Okay, so now our model is complete. We can close it and we can now view the results. So go into the results tab. You can select profile plots to see the longitudinal section. To the cross section, we can plot cross sections, and we can also toggle between different cross sections. Then we can also view the results in terms of a table in the summary output. So for this table, we are interested in the water surface elevation in OBS. So there you have it. You have now the knowledge to set up a 1D hydrodynamic model using GeoHECRAS. Thank you for watching and happy modeling.